Today I am going to explain why the DC motors should not be connected directly to the port pins of microcontroller, and what are the precautions we should take, and what are the driver considerations we should consider while interfacing DC motors with microcontroller. So before explaining, I'll show you the image of motor drivers. There are two motor drivers I'm going to explain now, L293D and L298N. These two are used to drive the DC motors. So in L298N, this is power supply section, 12 volts the voltage we can give to this pin. This is a common ground and 5 volts is available at this point. Then these two, out one and out two, these two pins are used to connect one motor, and out 3 and out 4, here we can connect the second motor. To control the first motor, I am using two input pins, IN1 and IN2. And to enable the first motor, to select the first motor, I am using enable A pin. Then for second motor, the two input pins are IN3 and IN4, and the enable pin is enable B. This is about the LN298N. In the same way, LN293D also is having the same pins, two pins for motor 2 and two pins for motor 1, and two input pins and one enable pin, and two input pins and one enable pin for the first motor, and this is for second motor, and 5 volt supply power for a motor we should give here, and ground. This is the pin diagram of L293D. So here in this we can connect two DC motors, and the first motor is connected between out 1 and out 2, and they are controlled by input 1 and input 2, and enable is used to select the motor, enable the motor. And second motor is connected between output 3 and output 4, and the speed is controlled with the input 3 and input 4, and enable is used to used for enable 3, 4. This pin is used for second motor. So what are the difference between L29? So even we can connect L293D and L298N. Before that, we should learn what are the difference between L293D and L298N. So I have listed here 7 differences, one after the other. The first difference is, let us differentiate these two drivers in motor channels. L293D, it is a dual H-bridge motor driver. Dual means it can control two DC motors, or it can control one stepper motor. So in L293D, two DC motors can be controlled, or one stepper motor can be controlled. In L298N, it is also a dual bridge motor, and it is capable of controlling two DC motors and one stepper motor. Same thing. Then in a peak output current, L293D, the output current per channel is typically around 600 milliamps. So because of 600 milliamps, it will be suitable for driving low power DC motors. Wherever you want to control or run low power DC motors, you can go for L293D. If you are controlling or driving high power DC motors or stepper motors, then you should go for L298N. The current capacity here is up to 2 amps. So the peak output current per channel is up to 2 amps. Here it is 600 milliamps. This is about output current. Then total package. The L293D, it is a 16-pin dual inline package, whereas L298N is 15-pin multiwatt package. It is 15-pin. This is 16-pin. This is about package. Voltage range. So L293D, voltage varies from 4.5 volts to 36 volts. And whereas L298N, it is 4.5 to 46 voltage range. And because of this, it is suitable for broader range of application. And the built-in diodes, both L293D and L298N have built-in diodes across the output pins. Why the built-in diodes are connected? To provide the back electromotive force protection, for EMF protection. So these diodes protect the driver IC. It is used to protect the driver IC and also the other components from voltage spikes that are generated by the motor during transition. Transition means when the motor is turned off, the back EMF is produced. So this will damage the driver IC. In order to protect the driver IC from the back EMF, and the built-in diodes are connected in L293D and N. And the sixth difference is control logic. L293D, it is a TTL logic compatibility, transistor logic compatible. And it is suitable for interfacing with microcontroller and other digital logic circuits, which are operating at 5 volts. Whereas L298N, it is TTL or CMOS, complementary metal oxide semiconductor compatible. So it allows to interface with a wide range of digital logic circuits and operates at varying various voltage levels. But L293D operates at 5 volts. Then internal protection, L293D, and the features are thermal shutdown protection to prevent the overheating. If it gets overheating, then it automatically turns down or shuts down. And in L298N, along with thermal shutdown, it also has over temperature, over current, crossover current protection mechanisms. So extra features. So which makes it more robust while handling the various operating voltages, load changes, various operating conditions. In such case, L298N is used. Then what are the applications of L293D and L298N? L293D, it is used in low power applications to drive small DC motors, small robotic projects, toy cars, and other small scale projects. Whereas L298N, it is suitable for high power applications. High power application where high current and higher voltage wherever it is required, it is used. So they are used to drive large DC motors, stepper motors, industrial automation, and other higher power projects. Next, the connecting DC motors directly to the port pin of microcontroller. What happens? This is very, very important while doing the project work. We should not connect DC motor directly to the port pin. If we connect, then why we should not, what happens and why we should not connect directly? Current requirements, DC motor draw a significant amount of current. So because just now you studied the L298 693D 600 milliamps and L298N 2 amps up to 2 amps. But DC motor can draw a significant amount of current, especially during startup and under load condition. The output pins of microcontrollers, they are designed for only a small limited amount of current. The port pins of 8051 microcontroller and whose current will be in the range of milliamps, not amps, in a few milliamps. So connecting motor directly to the port pin, what happens? It can exceed this current limit and it will damage the microcontroller. So we should not connect directly to the port pins. And back EMF. When DC motor is powered off, when it is turned off, or when it changes the direction, it can generate the EMF. It is called as a back EMF. This voltage can be much higher than the supply voltage. When back EM is produced, the voltage is very, very high. So it will damage the microcontroller output pins if not properly managed. Therefore, we should connect L298N or L293D to provide protection against the back EMF by using diodes or by other methods. Voltage compatibility. DC motors typically operate at higher voltage than the microcontroller output voltage. Directly connecting the motor to the port pin may lead to voltage compatibility issue and it will damage the microcontroller. And control and efficiency. Drivers like L298N and L293D, they provide more control over the motor. So they can control the speed, they can control the direction, and they also improve the efficiency of the motor using the PWM technique. So for all these reasons, we should not connect the DC motors directly to the port pins of microcontroller. So if you were to connect DC motor directly to the port pin of 805 microcontroller without any precautions or without any driver circuit, definitely several things will happen. So the motor might not receive enough current to operate correctly. Motor wants more current, but microcontroller is able to, port pin is able to supply only few milliamps of current. So which is not sufficient to drive the motor. So leading to erratic behavior or no movement at all. We just get a sound. There will be no rotation of the shaft. So this thing happens. If you get a sound and if the shaft is not rotating, you should understand that it is not able to get the sufficient current from the controller. So the excessive current draw from the motor could damage the microcontroller output pin. What it will do, it will try to draw the excess current from the microcontroller port pin. Definitely the port pin will get damaged. And when the motor is stopped, back EMF is generated by the motor, so which will cause the voltage spike and definitely the microcontroller gets damaged. So to work with the DC motor safely and efficiently using 805 microcontroller, it is advisable to use motor driver ICs like L298 and L293D. It's these two, either one of them you should definitely use. So here are some precautions to take when working with DC motors and port pins. Use a suitable motor driver IC, either L298N or 293D to interface the motor with the microcontroller. Connect the motor power supply separately. So we should, if it is 12 volts motor, if you are microcontroller, if you are connecting 5 volts, then you should use separate DC power supply. So that is very, very important. Connect motor power supply separately. Use flyback diodes or freewheeling diodes across the motor terminals in order to protect the EMF. But if you connect L293D and L298N, they will have the inbuilt freewheeling diodes, which will protect the motor driver IC as well as a microcontroller. And you should follow the data sheets and specifications of motor driver IC. So, and the microcontroller for proper connection and current limit. Current limit checking is very, very important. Use decoupling capacitor near the motor and driver IC to filter the noise. So that is already there in L298N and L298C. Implement proper motor control algorithms. You should go for PWM techniques. We can control the speed of the DC motor using potentiometer also, but a good method is PWM for speed control to efficiently drive the motor. Avoid sudden changes in the motor speed. Immediately, you should not change the speed of the motor or the direction without proper acceleration and deceleration routines to prevent the stress on the motor and driver circuitry. So by following these precautions and using appropriate driver circuitry, you can safely and effectively control the DC motors using 8051 microcontroller or any other microcontroller platform. So these points are very, very important. Before doing project using the DC motor, you should go through all these points. Then you choose the proper motor driver and the module, then connect the DC motors either with the microcontroller or with 8051 microcontroller or Arduino Uno boards or Node MCU. So this is all about precautions and driver consideration when interfacing with DC motors with microcontrollers.